guys. I wanted to continue our benchmark review. This is the paper that it's like 3 pages. We finished off yesterday with simplifying exponent expressions, and now we're going to go on to scientific notation and talk about that. So scientific notation, if you remember, was a really a shortened way to write really big or really small numbers. And we used it by moving the decimal and counting our spaces, not our zeros. So in the notes, it says scientific notation to standard notation. Move the decimal to the blank if it's positive, and to the blank if it's negative. So if the exponent is positive, then we're going to move it to the right. If it's negative, we're going to move it to the left. We didn't think of it this way. What we did is we thought of it as a big number or a tiny decimal, and that's how we viewed it. So these are the notes so that you can fit in those 2 blanks that are on the page right here, right and left in those 2 blanks. And then we'll look at the examples. I'm going to do different examples than the ones on there, and then let you have a chance to do those examples. So an example like the first one, example A, I'm going to put 5.6 times 10 to the 4th. And we want to write that as a regular old big number. How do I know it's a big number? Tell your neighbors or your dog or your brother or sister. How do I know that's a big number? Okay, if you've forgotten or maybe you didn't, this is positive. That means that if that exponent is positive, it's a big number. Also, our notes say that that means we move to the right. We want to make this bigger than 1, so we're going to go to the right. 4 spaces. Please remember that it is spaces, not zeros. So if I have 5.6, I'm going to go 1, 2, 3, 4 spaces. In those blanks, those 3 blanks, I put zeros. So it's 5, 6, 1, 2, 3, or 56,000. Think real quickly, why are there only 3 zeros when the exponent says 4? Good. Hopefully you say it or think it. It's because 4 tells me how many spaces, not how many zeros. And one of the spaces was taken up by the 6, so there's 3 more spaces left. This is the same number here. 56,000 is 5.6 times 10 to the 4th. Okay, now what I'd like you to do is do example A, the real example A on the paper. Pause the video, try it, and then I'll do it on my on here. So the problem we're doing, in case you don't have the paper in front of you right now, 6.23 times 10 to the 7th. And I want you to write that in standard notation, which means the big number that it equals. Okay, pause the video, try it. Okay, hopefully you saw that there's 7 spaces we're moving. 2 of those spaces are taken up by the 2 and the 3. So that means that there's only 5 zeros in this problem. There's 7 spaces, and we have 2 spaces taken up by 2 and 3, so 1, 2, and then we have 5 more zeros after that. So you go 62, and then 3, and then 0, 0, 0, 0, 0. When I put my commas in the right place, that should be 62,300,000. Okay, let's try B. I want you to try this one. I'm not going to give you an example like it. I want you just to try this one. It's 8.4 times 10 to the negative 4th. Press pause, check your answer. Okay, did you get an answer? Did you try? Even if it's wrong, I want you just to try. So here's how we do it. It's a negative exponent, which means we're going to move to the left, or we're going to make a tiny decimal, something less than 1. We're going to go 4 spaces because this tells us 4 spaces. But one of those spaces is taken up by the 8. That means we only have 3 zeros. So 0.00084. Okay. I'd like you to try going from standard to scientific. We'll do that in the next video.